In this video, we're going to take a look at how to write a sinusoidal function given the graph, and we're also going to take a look at an application of sinusoidal functions. So to begin, you want to identify A, B, C, and D, which is the amplitude, period, phase shift, and the vertical displacement for the graph, and then I actually want to take a look at how to write the graph in sine form and also in cosine form. All right, so to begin, let's take a look at this first graph here. So we can see that our central axis is right on the x-axis. So by doing this, or looking at this, we can see that the amplitude, whether we measure from the top to the central axis or from the central axis to the minimum point, we can see that the amplitude is 4. Now, it doesn't matter whether it's a sine or cosine graph, the amplitude will still be 4. So next we're going to take a look at the period. And to define the period, what I want you to do is to take one point from the graph and go to the next point where it would complete one cycle. So in this case, this would have to go all the way until 2 pi before it then repeats again this piece here from 0 to 2 pi. So the period is 2 pi. However, that is not actually what our b value will be. So since period is equal to 2 pi divided by b, the b value is equal to 2 pi divided by the period. So in this case, our period is also 2 pi. So therefore, our b value is going to be 1. Next is phase shift, but I'm actually going to come back to this, and we're going to look at vertical displacement first. Now, since the graph hasn't moved up or down, we can see that it's equal distance from the central axis to the max and min. The vertical displacement is actually 0. Now, the reason I'm going to come back to phase shift is because it's actually different if we're looking at the sine graph or if we're thinking of it as a cosine graph. So let's think of it as a sine graph first. So if we look at it as a sine, remember the sine graph, I'm going to draw it over here very small. It looks something like this. And we actually have something that looks like that if it's shifted over by pi. However, when we're writing equations, we want to usually have the minimum phase shift. So if we take a look, if I flip this basic function and flip it upside down, I actually don't have any phase shift at all. So I'm going to say that the phase shift is 0 for sine. However, this will now say that the a value is going to be -4. So originally, now I didn't write this down, the amplitude gives me an a value of 4, but when I want to use a sine graph or use a sine function, it's going to be -4. Now for cosine, we want to do the same thing. We want to find a place where we actually see this graph that looks like this. We have a couple of options. We can start over here and think of this as our cosine graph, which means that our graph has now shifted over left by pi over 2. Or we can think of it as this graph here, which I'll color in black, and it's going to shift right by pi over 2. But then when we do that, the cosine function is also flipped upside down. So to make it a little bit easier, let's leave this as -pi over 2. And that's going to be for cos, so that then our a value will actually be positive. All right, so let's make a little chart here. So we have sine and we have cosine. Now, it doesn't matter whether it's sine or cosine, the amplitude is still 4, but it's going to be -4 if I want a phase shift of 0. For cosine, this will be 4. Period, the period doesn't change whether it's sine or cosine, they're both going to be 1. And same with my d value, my vertical displacement, both of them will be 0. So it's my c value that's going to be different. So for sine, this will be 0. And for cosine, this will be negative pi over 2. So I'm going to write my two equations. And I have y equals negative 4 sine, and my b value is 1. So it's just going to, and my c value is 0 and d is 0. So really I only have sine theta. For cosine, I have 4 cos, and then I have 1 for my b value, which I don't need to write anything down, and then theta minus c. So since my c value is negative pi over 2, sorry, this will be plus pi over 2. All right, so let's take a look at the next graph. So this one here, we do have a vertical displacement. If I figure out and draw this central axis here, it will be easier to see what my amplitude is. So you want to draw your central axis so that there's an equal amount of graph above and below the central axis. So from here, I can see that this is 3 spaces, and this is also 3 spaces. Check my scale. You can see my scale is every square is 1. So that means that my amplitude is 3, which implies that A equals 3. My period, again, I'm going to find a place where it repeats. So if I take this point here and I go to the next point, it is 2 pi. Now I didn't state this, but I can also pick a maximum and go to this and then you can also see that this is a distance of 2 pi. So again, my b value is remember it's period equals 2 pi divided by b, so therefore b is equal to 2 pi divided by my period, which is also 2 pi. So in this case, excuse me, the b value is 1. All right, so let's take a look at phase shift. If I look at my sine graph, I'm looking for this shape here, and remember it starts in the central axis. So if I follow this point here and follow this along, I will have that shape that I'm looking for. So we can see that this gives me a phase shift of pi over 2 to the right. So this is going to be positive pi over 2. And that will be for sine. For cosine, I am looking for this shape here. And I can see that I get this, but it's flipped upside down. And so therefore, my phase shift is 0 for cos. Okay, lastly, my vertical displacement. This is where I drew my central axis, and I can see that I had to draw my central axis 2 spaces down. So therefore, my vertical displacement is negative 2. So creating a little chart just to help me organize my information. My A value is 3. Oh, and I forgot to say something. So because the phase shift is 0 for cos, this now implies that A must be negative 3 because I've actually flipped my graph upside down. All right, so therefore this is going to be negative 3. B value is 1 for both sine and cos, because sine and cos does not affect the period. It's going to stay the same whether it doesn't matter which function it is. We have pi over 2 for sine, 0 for cos, and then both of them are negative 2. So writing my equation, I have y equals 3 sine. My b value is 1, but I have a phase shift of pi over 2 for sine, and then minus 2 to say that it's moving down. And then for cos, it's y equals negative 3 cos, and then theta minus 1, theta minus 0. So actually I don't really need to write that in. So I have cos theta and then minus 2. All right, let's next take a look at applications. So here I have, my question says that I have a height of a chair on a Ferris wheel and it varies sinusoidally with time. So the radius of a Ferris wheel is 12 meters. So I've actually drawn a Ferris wheel here. So I know that this distance here is 12, and this distance is also 12, because it says the radius of the wheel is 12. The wheel rotates once every 40 seconds. So if I start at 0, it will end at 40, and that will give me 1 period. A person sits 14 meters above the ground, and the wheel is rising when the wheel starts to rotate. So we're going to assume that the person gets on here at 0. And we know that this person sits at 14 meters. So this height here is going to be 14 meters. So I'm going to, oh, sorry, hold on. Let's go back. The lowest height is 2 meters above the ground. So let's start this again. So this height here, is 2 meters above the ground. So this point here is 2. Now this fact that this person sits 14 meters above the ground as it's rising means that the person starts actually at this point here and not down here. Since 2 plus 12 is 14. Now to give me the total height, I have 2 plus 12 plus 12, which tells me that this maximum height is 26. Now it says that here that the person is rising when the wheel starts. So the reason we want to know that is it's going up instead of coming down first. Okay, so we're going to plot some times. It takes 40 seconds to complete one rotation. So I'm going to plot maybe my 40 over here. And that tells me that this is going to be 20, 10, and then 30. So at the 40-second mark, the person should be where they started from. They rise, and a quarter of the way they should be at the top. So that 10-second mark. At the 20-second mark, they should be halfway. And they should have rotated back to the same height as they were before. Then as they continue down, so imagine this person is going up, back to the other side, the same height, and then they come down to the 2 meter mark down here. So I'm going to connect my points to give me a nice curve. And then what I'm going to do is I'm going to translate this information to give me an equation for the height of the person. So if you take a look at the value of A, that is going to be my amplitude, and that will be 12, whether it's sine or cosine. The value of B is my period divided by, it's going to be 2 pi divided by my period. So this will be 2 pi divided by my period, which takes 40 seconds to rotate. So that's going to be pi over 20. So both of these will be pi over 20. The value of C, there's no shift in sign, so this will be 0. But if we take a look at cosine, we want to start probably up here and then get this shape over here like this. So there's a phase shift of 10. Okay, and then lastly, we want to find our vertical displacement, and we can see that our central axis is here because there's 12 meters above the central axis and also 12 meters down, which makes 14 our vertical displacement. So from here, I can write my equation, and because we're talking about height and time, I'm going to use h of t. So height is dependent on the time, so we have 12 sine, my b value is pi over 20, and I can put t, because there's no phase shift. I can actually open a bracket minus 0, but I don't need to. And then I'm going to put plus 14. If I'm writing a cosine equation, this would be h of t equal to 12, and this will be cos this time, pi over 20. Now I do have a phase shift, so I need to open a bracket and write t minus 10, close a bracket to say that this whole piece is what we're going to cos, and then we have to add plus 14 to give me a vertical displacement. And this is how you write the equation for sine and cosine for this Ferris wheel problem.